So, welcome to our live stream about PMA cable protection solutions in application on rail. Before we start with all the details, what to use where, and you hear it, we are here in our production. And here we produce all the products made of plastic, corrugated conduit you see here on the machine, as well as the fittings on the other side. And you see, I have to move my mask a little bit. And here I would like to have the first most important statement. Health and safety. Health and safety is our top priority. There is nothing around it, so to say. So health and safety, that's also the reason why, for example, when I'm here, I'm wearing the glasses, I'm wearing the jacket, as well as the special shoes where there is protection inside. And of course, here we also wear the mask, because it is possible that we come too close together with other people to be safe of corona. Later in our presentation, we will be in a special room where we organize everything, and I'm looking forward to be there because then I can take off the mask and talk more clearly directly to you. Now back to PMA. Here we produce with roughly 100 people about 500 kilometers of corrugated conduit and about 500,000 of inject molding products per week. We do the plastic, and that is our competence. And now we would like to walk with you through our production. So here we do the corrugated conduit. Different sizes. Now, at the moment, the same color, all in black, and also one of our, of course, needed things is automation. So there is a lot of automation, that's why you don't see too many people here. As an example, here we have the automatic coiler. So the produced corrugated conduit is automatically measured and coiled to the right length. Of course, quality. We talk about Swiss made, so your expectation of quality is high and has to be high because we can fulfill the quality you would like to have. And the quality is actually on us. And you see it over there, the people are doing inline checking of the different things. That can be the weight, that can be the visual things. There are a lot of different things they have to check. And that right now my colleague is noting it. And then we will put everything into our system. Oh, great. Now just the book is on the computer. So he's putting all these data into the computer so that even after 5 or 10 years, you come to us and have a question about a specific product, production size, so to say, or production lot. We can go and have all the details there. So now please follow me, because now we will go into the dispatch area. So I have to stop again because I remember that Hans-Peter told me I have to talk to you about PMA. Because not all of you are knowing what is PMA. PMA is a company established 1975, so more than 40 years ago. Why did we start with PMA? Because we saw that metal is okay, but there is a possibility to have better, more efficient solution made of plastic. So we are at the end, we are a plastic company. We are modifying our plastic and at the end to have a product fitting to your application. So the performance, quality, price, these 3 elements, they are really together when you choose a PMA product. There are others who say you can use everything for everything, so to say, but we exactly do the opposite. You tell us what you need and we make it possible that this product is doing what you would like to have from the product. So now let's go to our special room. Why is it a special room? Because in there we have built up our Mockup Train. The Mockup Train is something we actually did or prepared for the Innotrans exhibition, which is not taking place until 2022. So now we come here to the Mockup Train, where my colleagues Hans-Peter and Heinz are also present and will talk to you later on. First of all, I would like to go one time around the train so that you know what we are talking about. We start at the front with the coupling system, a little bit some application on the side, very exposed one by the way, the typical jumper cables, but also the connection on the roof. Before then we go into details about one of very special topics, and it's called EMC solution, so cable protection in combination with EMC. Make sure your signal gets to the right place and is not disturbed. Then of course we go for the inside of the train, which looks really like a real train at the end, even if it's only a mock-up, where we have some general information, and of course also the inside application, where we will show what to use, why to use, and all this about PMA cable protection. So the first part, my colleague Hans-Peter will take over and talk to you about the general things of the PMA product lines.
Martin, welcome everybody. I would like to give you an introductory on PMA. PMA is a plastic technology company creating cable protection systems for various applications. We have over 6,000 components in our portfolio, which actually cover all these requests from our customers. Now today, we would like to concentrate on a rolling stock application, where I would like to start to give you an input on a new product line we have created recently. First of all, very important, the conduit generations we have created, the multi-layer conduits, which are new next generation technology, which are used specifically and have designed specifically for railway applications. Furthermore, we have a new multi-holder system, which actually has been designed together with our customers, considering important factors like weight, like size, like universality, means we can not only hold conduits, but also now cables in various combinations, very, very flexible and highly sophisticated system. Now, would like to see a movie for PMA Fix Pro and multi-layer conduit. So, ladies and gentlemen, I'm back again, and we are talking about the next unit on this Mockup Train. It's the train coupling system, which is highly exposed to weather, temperature, climate, combined with the speed of the train. So, what basically is the ingredients for a high qualification material as well as a high qualified system. First of all, we have most of the time two parallel lines being guided into the train body or on the undercarriage containing power cable, signal and sensor cables. Concerning the water ingress situation, IP68 and IP69 is actually possible. Here we see now the PMA Fix Pro being used due to the fact, as I mentioned before, high exposed area, making sure that we do not have any water ingress into electrical systems. Also, we have different types of coupling systems. This is one part, but sometimes we only have one line going in or different setups, and basically we have a large variety of parts which also being used for different designs. Now I would like to show you a movie with the IP water ingress protection.
So, you saw now this impressive movie in a dynamic test of our IP69 solution called PMA Fix Pro. And did you see this little paper coming out of the fitting was absolutely dry. But that's not the reason why I'm talking right now to you. I forgot, and that's the advantage or disadvantage of a live stream, I forgot to mention that of course we're open for questions like always. We do this not live, so to say, but we installed an email address which is pma-conduitsystems@ch.abb.com. That is pma-conduitsystems@ch.abb.com, where we ask you to place your questions. Shoot as many as you like to, all the details you would like to share with you. Maybe we cannot share all the details with you today, but at the end of the session, we will have a question and answer part. And if there are too many questions, we will answer them later on. But some of the questions we would like to ask when it is kind of really fitting the topic. And now I'm cheating a little bit, because in the morning we already had a live session, and there we had a question from the coupling system side, where I think it's quite interesting and most probably good for all of us. The question was, what kind of form of fitting are available for PMA to have a solution on the coupling system? Hans-Peter, can you answer this?
Yeah, due to the fact that we have different designs on couplings, we also have prepared, and as I mentioned before, we have many parts in our product portfolio. So here you see, for example, IP69 Fix Pro fitting, which has a 45-degree angle, getting off the coupling system, but there are also 90 degrees available or straight versions available, depending what type of design we have, that the customer has actually chosen to be put on a train.
Thank you very much, Hans-Peter. So now we will continue and go to the side of the train, where we will talk about some other application. What kind of application would I like to share with you? Outside of the train. Actually, we have installed here on the Mockup Train two of them. One is a sand dispatcher, I'm sorry that I don't know the word in English, which has the function to make sure that the train, if it is wet, slippery, cold, whatever, that there is a unit which can dispatch some sand on the track to get the traction, so to say, so that the train can start moving. You see it here. It's quite an interesting unit. There is a heating system inside, Because when it is wet and cold, the sand, they could stick or freeze actually together. So it's a heating element inside. And also inside, there is a magnet opening and closing the valve here so that the sand can drop out. So heating, magnet, that definitely leads to the conclusion there's cable inside. And yes, there is cable which is into this corrugated conduit. And you can imagine, it is on the outside. So if there is something laying on next to the track, if there is a bush or anything, which will definitely hit this one. Also, if there happens accident or so, there is definitely a lot of stress in here. So that's why we use here our multi-layer technology we use for the corrugated conduits. Here we would most probably recommend an XVCSF, but that's already going too much into details, because we have also some other solution for the conduits. More important, or more to the details, I would like to go with you is with the fitting. You see it here, and it's the same, coming from the same family, from the PMA Fix Pro IP69. And to go more into details why IP69, I would like to move backwards to our other thing we installed on the train, which is a wheel sensor counter, so to say. Most of you know, they look like this, it's a real one. And here I would like to explain much more why it is important to have the right ingress protection level. And often this unit is installed like it is here, it's like reality, even if it's only Mockup Train, and you see this fitting is going in the direction or anti-direction of driving of the train. So all the water coming from here when it is raining is actually pressed against the ceiling inside of the fitting. And hey, we have here trains going around in Europe with 200, 240 kilometers per hour. There are places like in Japan, they go even over 300 kilometers per hour. So you can imagine what kind of pressure this gives when the water is coming here on the fitting. And here we can really guarantee you there is no water going into the system. That's why we, on this kind of application, first of all, recommend to, if possible, install it on this side, so that it is against the wind, so to say. But like I was saying, sometimes it's not possible, and then we do it on that side. Coming back to the conduit, like I was saying, they are quite exposed. And to give you a little bit of insight, what do we do to make sure and actually check that this is the right product to use? We make some tests in our laboratory. And we will now show you a little movie how we do this.
Hello to all of you. I want to take the chance now to give you some information about the Pma Emc system. So we have to go around a little bit the train. Here we have a panel installed where you can see the topics. What happens here is that a normal PMA system, cable protection system, can be upgraded with some products to be has the functionality of the EMC. So what we need for that is, on one hand, a braid. You see it here in this case, it's a braid inside the conduit system, and mainly in both ends of this conduit, there's as well some special metal parts, some special metal fittings, who grab the braid to contact them to earth, and in this case as well have the possibility to sealing the cables inside. Normally we use the tin-plated copper wires. That is a solution like this one here. That is a pure metal where you have a screen value up to 70 decibel. And this coming back especially to this braid, that looks a little bit different. That is we call it a hybrid braid. It consists on metal parts and as well the red ones here, that is polyester monofilaments. Why we do this? This product has a very high strength against bending. So that is really the the product using in kind of jumper cables, whatever. Of course, there's plastic inside. It has to be tested and certified against the European norm. It is the EN 45545, and in this case as well against the North American norm called NFPA 130. So that is a complete system. When we come to the fittings here, as I said before, this kind of fitting, inside this fitting there's a connection from earth to then, if this would be metal, to the earth. And here you see in this case as well sealing for the two cables. We have here the big brother of it, that is a really installed system. You can see here that is much more than two cables only inside. So you can it as big as possible, so like size 48 is the maximum. Showing this sample here in the middle, that is as well out of a project in Germany. This is a little bit different. So when you have here on the right-hand side a space where it's electromagnetically shielded inside the conduit. In this case, we have a shielded cable inside. And with this here, you can grab the screen of the cable and put it, in this case, to earth as well. So it's not only, it can be used for both applications. So inside a braid or a shielded cable inside to protect it against mechanical strength. The last one on the left-hand side is as well as a little bit special. You see there are two blue cables. The blue cables are Cat 7 cables. And both of the cables have a screening. And in this case, it's a special one that you can have a grommet where you can seal it. And in the next step here in the metal part, there's a kind of fixation inside, which is really easy to have termination to the screen of the cables. So both cables are screened individually, not as common, but individually. So what happens, now we talked about the EMC parts, but what happens about these conduits and all the other stuff? So the conduits itself, as you see it here installed, can be used for this application. It's only an upgrade, as I said. And the conduit will be chosen by the applications on the environment. And what we test in there, we want to show another movie. It's about compression strength, so how we are measuring the compression strength.
So now we are back. Before we go for the next topic, which I will talk about roof installation, I got questions. Thank you for this, for sending in questions. Keep on going this, but there is one which is related to what Heinz just talked about, EMC solutions. And the question is, which conduits can I use with EMC solutions?
Every conduit out of our portfolio. So it's independent of the size. I think we start with size 10 in this case, up to size 48. We have all the fittings available and the braids available, but you will just see for a few seconds.
Good, thank you. So then let me go on the on the roof of the train. Meanwhile, the cameraman is going around the train, so that I can talk a little bit about up here. So what is it? It is a connection between two wagons, locomotive, wagon, whatever then it is. And there we have to make sure that the cables run all the way. Sometimes on the side, sometimes they're in the middle, sometimes they're below the carriage, but here we talk about on top of it. The main thing I would like to tackle at the moment is the holding system. Most of you know this holding system here, typical PMA holding system, quite easy, put in the conduit, close it, and it is done actually. Also, this system is used by the thousands on the trains, because you can also stack it, so you can also do something like this. You see a bigger size and smaller size. But you see, it is, it's heavy duty, it is heavy, so to say, it's very robust, very good, no doubt about this. But you came to us and asked for a new solution. lighter, better, cheaper, faster, all these superlatives we all know. We have been working with some of you very closely, and thanks for your support, to develop actually this kind of multi-holding system. Why did I stretch the word multi-holding system? Because now we go even a little bit further or behind. We are a cable protection company, so we do cable protection systems with the fitting, with the corrugated conduit. But here we went further because you asked us, can you not make something where I can also fix my cables? I said, oh, okay, new things for us to do. But we did it. So we did this kind of a rubbery, soft material which you can put in our latest, newest multi-holding system. This multi-holding system is about 90% of all the different types are available. Why only 90%? Because we have 1, 2, 3 and 4 folds, so all the way from size 10 up to size 48. I will not do the calculation how many parts these are, I can just tell you it's a lot of parts. Why do we do this? To give you the flexibility and possibility to have the best possible solution by using 1, 2 or 3, whatever is needed, or even 4. So that's one thing. The other thing is the flexibility here. It is, we can put in this kind of rubber solution to hold the cable. We can put in more solid plastic or PA6, specially modified, so that we have an EN 45 by 45 HL3 approval and an NFPA 130. You can also push this in. Of course, then you put in the cable and the corrugated conduit, push it together and close it. So you can imagine here you have a size 29, so a smaller size of conduit. Here you have a cable, and here you have the big size of the conduit. And we even could reduce this in kind of an onion system all the way down to size, I think 10 or so. Heinz just mentioned we can reduce it. If it does make sense, I'm not so sure, because I can imagine it looks kind of strange if you have this kind of holding system and this kind of rather thin corrugated conduit inside. Nevertheless, if needed, we can do it. In reality, it looks like this. So you see here, it's a cable. Back here we have a cable installed. Here we have different conduits installed. And to give you more confidence about this is the best possible holding system, I would like to show you a movie. Next time we do this movie live, we go into the laboratory. This time, because it's the first time we do this kind of live streaming, we will show the movie and I will be the voice talking about the movie. So you see Reto in the laboratory, and that's one important thing. Please always, when you tighten something, use this special tool to make sure it is tightened correctly. Because plastic is rather not soft, but kind of softish, and then you push too much and break it. Here what we do, we simulate the cable. This metal rod is actually by the norm a cable, and we put in this tape to show you how much it is moving when you are pulling with a lot of force on it. On the left hand side you see 0.6 millimeter where we just cross the line, and that's where we stay even after hours. So the cable is really fixed in there. The same thing or similar thing we do with a corrugated conduit inside. And you already saw it was already jumping. Why was it jumping? Because there was a lot of jumps coming out of the holding system. Now how much weight did we use to pull it out of this holding system? 10 kilo, 5, here we have it. 800 Newton meters, so that means over 80 kilograms was needed to pull out the corrugated conduit through this holding system, and this quite in a stable way. Also important for us is, if something like this happens, which is normally by an accident, the system should be reusable. It should not break. And that's what you see or saw in the last picture. We do now the same thing with a reducer inside, because this could be that it is kind of loose and jumping out. It's also not so easy to fix it good enough, but not too strong. With the not too strong, I come on later on, why does it not have to be too strong? So we have the same thing with the elongation of the time it slips through the holding system. Again, nearly 80 kilograms, a little bit less. You see it here on the graphic, but still on a very good level. So I approximate my weight, I could actually hang on this system and will not fall off. Now Reto will also show us the inside. Is it broken or not? Is maybe this reducer broken? And you see these ribs inside completely there on the complete body as well as on the reducer, so you just can reuse it. The other topic, when you walk on the train, and that's happening when you do maintenance, quite often they stand on our nice holding system. So here we press with a 50 by 50 millimeter plate with, I have to see, 150 kilogram, we press on it. So nobody of you is so heavy, I assume, so that's definitely nothing happening. We do the same test above this rib, which is quite a difficult place to be because they could really dispatch easily. So 150 kilograms pressed on it, so we see here now the graphic. And what does it show? I don't know yet. The same. So there is no, nothing happening if even somebody really heavy stands on our holding system. So then let me now go back on the train to talk to you why it should not be fixed too much. Because you could easily hold this conduit and hold it like a bear, I don't know, any other animal. But the most difficult energy to absorb for a corrugated conduit is actually this one, torsion. Torsion, you can imagine if you would take, let's take a bunch of spaghettis, dry ones of course, not cooked ones, dry ones, and you do this one, it will, and you will have a spaghetti soup because all little parts will break apart. It's kind of the similar thing happening inside of the plastic by the nature of the plastic. We can do what we want, that's the nature of the plastic. So it is important that we take away this energy. And like I was showing here, you can turn this one. So we can turn and turn and turn. So if this train is moving, going all the way around the curves, vibration, this one can move so that it is not getting this stress on the plastic and breaking after, I don't know, a couple of months, years, whatever. And that is why we cannot fix it into our holding system. Also, our holding system, of course, is used already on some jumper cables, so to say, above of it, like in this kind of system. It's easy to stack together. This we will show later on in a quite nice movie. The last thing I would like to discuss with you is about this in front of here. That's a different application. We call it a fire barrier, that's right, most probably the right word, a fire barrier. And fire barrier solutions, we offer 3 of them. We have one for E60, so 60 minutes withstanding the fire, one E30 and one E15. I will shortly talk about the E60 one, and there also, we are a specialist in doing plastic. We are specialists in doing cable protection system. We are not specialists in doing fire barrier system. But there is a company out of Sweden called Rocksteck, and some of you know it, with these blue elements, making sure that this quality or this performance at the end, because quality is just the performance you expect, this performance is according to your needs and fitting perfectly together with PMA, because they are expert in this one, we are expert in the cable protection things. So with this solution, you see they use the same kind of technology in an onion system, like we use on our multi-holder. You can put at the end of a fitting and you have an E60 approved fire barrier. With this, I would like to move over to a short video where we show some more details. So I'm back. You see now I got the laptop because there are really a lot of questions coming in. And one I would like to answer directly from myself. Can I use different manufacturers' fitting with PMA multi-layer conduits if the conduit fittings are already specified? As long as it's written PMA on it, then yes. Or in another way, you can do what you want. But we do strongly, very strongly, not recommend to mix, because the mix and match approach is not working. It's not because we don't want these kind of things happening. It is much more because of the norms existing. And there is no norm very specific about cable protection. There are norms about ingress protection. You heard it from my colleagues about the IP rating. There are norms about fire behavior, but that's more the material inside, but not about the cable protection system. So all the different manufacturers you have around the globe, they are kind of similar, but not the same. So our strong recommendation is don't mix them. For example, I showed you the turning of the corrugated conduit in the multi-holder. I can stand here and say, this is working with a PMA conduit. I will never do this with a not PMA conduit. So the answer is up to you at the end. With this, I would like to get now to Hans-Peter, who will talk about the Chomper cables.
Yes, thank you very much, Martin. The next topic is Chomper cables in between cars. Here, what you see, you have several solutions here, PMA solutions, which are representing different type of trains. And just as an assortment to see, I mean, we have different trains like high-speed trains, like subways, like EMUs, and so on. So we have different solutions and different issues. So I would like to really separate this presentation in two. First of all, I would like to talk about the issues to consider for Chomper cables in general on trains. And Heinz afterwards will actually explain the different components used for different solutions. So, issues we have to face here. First of all, we have space limitation. And certainly, I mean, Martin was mentioning this also on the roof, that we have tension and torsion issues to take care of on one hand, and on the other hand, each train has a different track profile to run and also different movements to take care of. I mean, just considering running over a crossing or a track deviation, so on, you will have extreme movements and extreme dynamics actually developing between the cars. Not to forget all the vibrations which are happening on a train anyway. So actually this has an effect on what kind of solution we use for different cases in the train building between cars to bring cables from one car to the other. So at this point I would like to have Heinz on explanation on different solution topics here on the intercar connection. Thank you very much, Heinz.
Thank you. Yeah, as I said, we want to talk a little bit about the products. So you heard about the severe conditions where these jumper cables have to withstand during the lifetime expectancy. And this lifetime expectancy is quite high, talking about 15, 20 years when you talk to the company. So it is important to have as well from PMA the right product for it. So we have designed the products, the XPCS, for example, which is installed here in the front. It's a HL2 product, so it's called, and as well tested to the North American norm. This is really designed for this kind of application. So dynamic ones in the cold, in the UV resistance, in the weathering. That is fulfilling the requirements the customer is asking for. The bigger ones you see here, that is called an XPCSF at the end. That is a product designed for the same applications, of course, like you see here, with an HL3 certification. Coming to the fittings you see here, So we installed and proposed to use in this kind of application our PMA Fix Pro. We have installed here, I would say, kind of open system, so the wires and the cables can directly into this interconnection here. And in the background you see fitting which has a strain relief inside. So in this kind of fitting you can seal the cables, the wires against the interconnection. And another big part is that the sealing or the grabbing the cable is important in case that the interconnections can be damaged when there's too much movement on it. Here we see another one. It's a metal part here in the background that's called SWA. We already heard about the moving of the carriages and what happens then to the conduit. And to avoid this, this is a fitting, so a swivel adapter like it's called. And we have here a big one. So if you have here the conduit and here the socket again, it works like this. So the torsion will be grabbed here and not on the conduit. Another detail we want to show is maybe realize that here you see something blue. Here you see nothing. The most of the fittings we are delivering with a flat gasket like the blue one or with an O-ring. The customer can decide by his own experience or by the kind of interface which one he wants to use. That's one point from my end as well, which we do not install, but we can show it. If you have more than only one loom here, it could happen that they hit each other, or they hit as well some parts of the train. So what you can do is we have here a kind of protector called BSS, and you can install it afterwards, really on the point on the conduit where it's really necessary. And another point is when the loom is too big or too heavy, in the end of the day, that you have maybe a critical point here with the tensile force, then you can use, of course, the already mentioned BGPM, for example. You can install it here on the conduit, place it together, and then, of course, fix it to the carriage. That is what we want to show to you about these applications and the PMA products doing for this. Now we have prepared a kind of movie, what you want to show to you. That is how jumper cables like that are tested from an OEM from us.
So here you see the old stone test. This is the test. There are two different levels for metros and for high-speed trains. It's a kind of, not norm, but accepted into the market. And we have the same here at PMA now laboratory, where we do exactly this test, so that we can do a pre-testing, of course, and also make sure that the conduits are made according to the needs. Additionally, I have another topic I would like to talk to you, and that was a question coming in by Nero. And the question was going direction of Heinz and actually of jumper cables, but Heinz can answer it. Question is condensation. What can I do to avoid condensation within the corrugated conduit system on jumper cables? Heinz, can you enlighten us?
Mm-hmm. Yes, we talked about already that is a strain relief fitting which we installed here at that place. That is our first suggestion to get this condensation theme out of it. This sealing of the wires inside the conduits is a kind of what is Trennung? Divided the rooms of the interconnection and the room of the conduit. So if the condensation occurs because of temperature reasons, then you have the very small rooms then, and the condensation, if they occurs, are quite low. So that is would be our first suggestion to you. Solve the problem.
Thank you, Heinz. And I think now you continue with the inside of a train. What does PMA offer there?
Okay. We can look here a little bit on the details here. In this room, we have installed some conduits and some braids. In general, you can say that, of course, the mechanical stress and the weathering conditions are inside the train is less stressful for all the products are installed. So in general, you can use lighter products or lighter conduits, lighter fixations, and as well the braids I talked before. On the other hand, the requirements of the fire safety standards are much higher than from the outside of the train. So HL3 inside means a lot more than HL3 for the outside of the train. So for this application, we recommend to use a VAML, for example, which has a European certification to the European norm and as well to the North American norm. Another conduit would be the PLR. If the train is classified in an HL2 area, you can use this one, of course, as well. Coming to the braids, there's two kinds of braids installed. You see that that is, in this case, it's a protection against the sharp edges in the wall. You can see here that is an open one. You can install it later on. So as soon as the cable is already installed, you can do it afterwards. And we see here the other black one, that is a closed braid, just for bundling the cables and give them a less mechanical protection. We have these conduits, or these braids. These braids as well in different colors, so in gray and black, that's more or less usual. But we have as well different connections here. You can connect it through this one, for example, to a plug, or you can fix it like this one here somewhere on the wall. So it's very good and easy fixation in this case. The next point we want to mention is this red installation. So that is as well a conduit. It's a VAML in this case. Wagner came a little bit more than 2 years to us, and they're looking for a system who can sample air out of a room and bring it and collect the air and bring it to a unit to have an early fire warning system. So we used, maybe you can see that in the details on the T dividers, for example, the sealing system behind is the PMA Fix Pro. And in this case, not because it's IP69 or 68. Remember, we are inside a train. In this case, it is chosen because it showed it is very usable as well when you have a vacuum inside the system, and that is here the case. So it's clearly where the air is coming from. It will not coming from the dividers. It will coming really out of the room, and so you have we could build up a very reliable system for the customer, which is easy to install, and which have a very high reliability in practice in real life. Okay, go a little bit in the back in the train here. For retrofit, we want to mention that we have as well some products. So retrofit means that the cabling is already existing, and afterwards we have to replace conduit or install it. We have here a system belongs of a conduit, of two pieces of a conduit that can be put together. In the end, it's a round one again. And as well, the fitting you see here and the lock nut can be divisible as well. So the whole system can be installed later on. Okay, so last but not least, we want to show you a little bit about firewalls. We already talked about, or Martin talked already about, on the roof we have a system, and we have inside a car as well a system. So a firewall is a part of the concept, of the safety concept of the train, and it divided neighboring areas from each other. So in case somewhere a fire is occurring, that this kind of firewall system should ensure that at least for 50 minutes, the other solution is for 30 minutes, the smoke and the fire cannot go on the other side of this wall. So we have two solutions for it, and the right hand showed a metal adapter where material is inside. This melts up the material when the heat occurs, and it's closing for 15 minutes, or in this case for 30 minutes, sorry, this room. So nothing can happen to the other side. On the other side, on the left-hand side, that is a fitting, a PMA fitting, including a strain relief. And this strain relief is as well tested in this situation to ensure that we have at least for 15 minutes. So E15 is a result of the test for 15 minutes deviation between the two rooms. Yeah, that is what we want to show you here on the train, because what inside applications does mean. We have now prepared another movie about the Pma system, how to install it upwards.
So, here we are back and coming closer to an end. Now we are in the part where we talk about questions and answers. Like I was saying, we got quite a lot of questions. We will not cover all of them. Some are very specific. We will answer them in a typical PMA manner. In one working day, you will get an answer. My colleague, our technical sales support guy, which is Nero, sitting next to me. He prepared the different things and different questions for me, which I'm really glad to, because he's doing all this at the same time. It's a little bit different. So you see there is Nero. So one question goes in the direction which I think it is worthwhile to listen to all of us to. It's IP68. This is something which is specified by the customer. How does PMA test IP68? I would like to give this question to Heinz.
Okay. So IP68 in the standard says it has to be a little bit more than IP67. So the requirements for IP67 is you have a depth of water of 1 meter and put the fitting, whatever it is, for 30 minutes under this 1 meter of water. So if you have information about the customer when we use it, of course. If you have no information, our test procedure would be that we just double both of values. So instead of 30 minutes, we go for 1 hour, and instead of 1 meter, we go for 2 meters. So for 1 hour, 2 meters, we test this product, and if it's dry, it's IP68.
Thank you, Heinz. Sorry, I have now to put down my laptop, and I'm happy that I took with me, you don't see it on the camera, but I took with me our demo case, where we have all our samples inside, so that's really great. Because we got also a question, can I upgrade my system? And this is something kind of rather simple. You just need these two PMA plastic parts, because you have an IP68 solution here, PMA fixed IP68, and actually as close as possible to the fitting or to the ending. You just click it on both sides, it makes click, you heard it, and with this we prevent the 80 bars or whatever pressure you have of the water coming here, and you can upgrade the PMA IP68 system to an IP69 one. One more sentence about this. We are testing, like Heinz was saying, according to the norms. But if we test this fitting, which we classify as IP68 according to the norm, in this very easy, not easy, but in this way that we install it, take it, let it drop into the water very slowly, stand away, wait for a certain time, very slowly take it out, you definitely have IP68. Same with IP69. You have IP69 also with this fitting, but we never would recommend this, and that's why we do, as shown at the beginning with Hans-Peter at the coupling system session, we definitely do an additional test, not because we want to do more testing, because there we can make sure that this product you are choosing, if you need IP69, you have IP69 not only in a static, that's according to the norm, but also in a dynamic application. And that is the key or the difference when you use PMA products. There were some more questions coming. When I need more technical support, where do I have to go? Of course, you saw the email address we just sent it. I think Hans-Peter can also give us some more insight on that one.
Yes, thank you, Martin. Basically what we have a global network on partners, and also due to the fact that PMA is mainly involved in projects, we have to have knowledgeable people in front of our customer door, and this we have for so many years, and our partners, they are being educated on a regular basis, so we have the knowledge right in front of the door of our customers. And basically we are not a wholesaler outfit which really supplies to wholesalers. We are specialists, and we also have specialists out in the field and in front of the customer stores.
Thank you, Hans-Peter. So I looked at the time, so we have 3-4 minutes left. Maybe that's an interesting one, challenging one for Heinz. When using single wires into a Chomper conduit system, do you recommend to bundle the cables with a tie wrap or not?
So my recommendation would be to bundle the cables, but use a braid for it. The thing is that if you have a tie wrap, the tie wrap has a head, and this head is a kind of, it's not round. So the risk what will take place is, or what can take place, that in this valleys, for example, in this case here, it is stuck somewhere. And then you have an abrasion inside between the tie wrap and the conduit. So yes, bundling makes sense in different cases, but from our perspective, please use a plastic braid for it.
Thank you, Heinz. The last technical question I would like to talk to you about, and now I walk in the direction of the camera, I know the cameraman doesn't like this too much, is why should I use PMA fitting and not another fitting? The reason is here. Also happily I had them in my demo case, and you see back here in this golden shining brass part, there are some black parts back here. And that is what we do special. The plastic is actually flowing or flying, I don't know the right name, goes right into there. Why do we do this? It's more complicated to make the nickel-plated brass braid thread, as well as it's more complicated to inject mold. But with this little thing back here, we increase the pull-out strength of this fitting tremendously. The other thing which we also do is the cables are here like my fingers coming through this fitting. Most fittings, they are just metal, outside of course, but also inside. And what we do, we inject mold all the way with the plastic all the way down here. So that when you have the abrasion of the cable going up and down here, because sometimes you have movement definitely, and sometimes there is some stress on it, we make sure that the abrasion is not as heavy. There is not no abrasion, that would be wrong, but it's not as heavy as if you can imagine if I would be out, even with the finger, if I would go with a cable over the metal, that is really then damaging the cable much faster, I would call it. That is the reason. Use the PMA solutions because of much better pull-out strength, so to say, much safer for the cable. So now I walk back, and I think we are coming slowly to an end. One thing I would like to mention is tomorrow we will do a similar thing, but not for rail vehicles. Tomorrow we go for the rail infrastructure. And you see already all the things installed here. So tomorrow at 9 o'clock in the morning, Swiss time of course, 11 o'clock in also Swiss time in the morning, and 4 o'clock in the afternoon or late evening, we will do a similar session about rail infrastructure. This session will take place in English 9 and 4 and in German at 11 o'clock. So please just go on our YouTube channel, PMA YouTube channel, and then you can join us tomorrow for an additional session. Thank you, and that was it.